Logic gates. What exactly are logic gates? In basic terms, they are a relatively simple digital electronic circuit. Each gate possesses two state signals according to a logical rule, and has one or more inputs and a single output. A logic gate can be thought of like a light switch, where in one position the output is off or 0, and in another it is on or 1. They are used by electronics engineers as building blocks for more complex circuits of gates or logic circuits, in which the output of the gate forms an input to one or more other gates for further processing. As they process two-state signals, it also makes them suitable for the processing and temporary holding of the binary numbers that computers use to represent numbers and text. So, as you've probably guessed, the processor in a PC consists of many thousands of logic gates. For Cambridge IGCSE and O-level computer science, you only have to consider and know about the 6 logic gates shown in this animation. You will need to remember the symbols for each logic gate, and know and be able to produce a truth table for each one. For the examination, you need to be able to remember the truth gate for a given gate and identify the gate from a given truth table. You will also need to know the logic notation for each gate. Okay, let's start with looking at the NOT gate. A NOT gate only has one binary input, A, and a binary output, X. The output is the opposite of its input, so it is also called an inverter. The output has the value true only when the input does not have the value true. In other words, when the input has a value false. This can be seen here in a truth table, where true is represented by 1 and false is represented by 0. A truth table is used to show the output of a logic gate circuit for all possible combinations of the input values. Even though it is called a truth table, we usually use binary values 1 and 0 as shorthand for true and false. For Cambridge IGCSE and O-level computer science, you only have to consider gates with a maximum of 2 inputs, except the NOT gate of course, which only has 1 input. Here is the logic notation for the NOT gate. Right, let's take a look at the AND gate. An AND gate has at least 2 inputs. The output has the value true only when its first input and second input have the value true. This is shown in the truth table here, where the only occurrence of the output X having the value true, or 1, is where both inputs A and B both have the value true. Here is the logic notation for the AND gate. Okay, let's have a look at the OR gate. An OR gate has at least 2 inputs. The output has the value true when either the first input or second input, or any other input or combination of inputs, has the value true. In other words, when one or more of its inputs has the value true. This can be seen in the truth table here, when the output has the value true in all cases except for when both inputs have the value false. The logic notation for this gate is shown here. Okay, let's take a look at the NAND gate. A NAND gate is an AND gate followed by a NOT gate. The output has the value false only when all its inputs have the value true. This is the same as saying its output value has the value true only when not all of its inputs have the value true. This can be seen here in the truth table, where the only occurrence of where the output has the value false is where both inputs have the value true. If you look back here at the AND gate truth table, you will see that the outputs for the NAND gate are the exact opposite to the outputs for the AND gate. The logic notation for the NAND gate is shown here. Okay, next, the NOR gate. The NOR gate is an OR gate followed by a NOT gate. The output has the value false only when one or more of its input has the value true. Or, to put it another way, its output only has the value true when none of its inputs has the value true. This can be seen here in the truth table, where the output has the value true only where both inputs have the value false. Again, if you look back at the truth table for the OR gate, the outputs are the exact opposite to the outputs of the NOR gate. Here is the logic notation of the NOR gate. The XOR gate. An XOR gate, or exclusive OR gate, acts in the same way as the logical either-or. The output is true if either, but not both, of the inputs are true. Therefore, the output is false if both inputs are false, or if both inputs are true. You can remember this by observing that the output is true if both the inputs are different, but false if both inputs are the same. This can be seen here in the truth table, where the output is false where both inputs are the same, and conversely, the output is true when the inputs are different. Here is the logic notation for the XOR gate. Remember, for the examination you will need to know the 6 logic gates covered in this video, and also know and produce the corresponding truth table for each gate. Good luck!